All right, Mr. Ahmed here for 7.4. Goal for today is going to be to start our factoring process. We're going to factor polynomials. And when we factor, really what we're going to be doing is we're going to be changing the format of the way that the polynomial is written. We are not changing its value. We aren't multiplying it. We aren't adding it. We aren't subtracting it. We are rewriting how it is written. And the process of rewriting it is really going to lead us to the easiest way to solve equations that include quadratics, so like x to the seconds. All right, we might solve a few x to the thirds or something, but not very many. Okay, so mainly we're going to be solving quadratics, and factoring helps us solve. All right, so first step. The first step in factoring is always to factor out the greatest common factor. Now, as a reminder from previous years, the greatest common factor is the number that is the largest that is a factor of both terms. So we have a 10 and a 15. So what number goes into 10 and 15? Well, factors of 10 include like 10, 1, 5, and 2. 10 times 1, 10's a factor, 1's a factor, 5's a factor, 2's a factor. The factors of 15 are 1, 15, 3, and 5. The greatest common factor is the common one that's the biggest, which is 5. Now, ultimately, if that's a struggle, then I'm not going to lie. I hate to be the bearer of bad news. This whole process is going to be a struggle. We have to be able to look at these numbers and know what times what's 9. All right, I can look at 9 and I know it's 3 times 3, 9 times 1. What goes into 21? 3, 7, 21, 1. I just need to know those for this process to be simplistic. If I don't, then I have to pull out the calculator and start guessing what goes into 21. Well, 21 divide 1. Well, 21 and 1. 21 divide 2. Oh, 2 don't work. 21 divide 3. There it is. 7 times 3 is 21. So that would be the process you'd have to use if you don't know them in your head. So the factors of 9 are 1, 9, and 3. Factors of 21 are 1, 21, 7, and 3. The greatest common one is 3. Okay, now I'm going to start doing these a bit more in my head. Factors of 20. I got 4, I got 5, I got 20, I got 1, I got 2, I got 10. Factors of 24, 6, 4, 8, 3, 24, 1, and 12, and 2. So there's a lot of them there. Which one's the greatest common one? Well, it appears to be 4. All right, for 9 and 14. Really, there's not a greatest common factor. The greatest common factor is 1 because the factors of 9 are 3 and 1 and 9. Factors of 14 are 7, 2, 1, and 14. So the greatest one's 1, so we'd call that prime. Or 1, I would call it prime. All right, factors of 30 and 12, greatest common one. 6. Okay, 6 goes into 30, 6 goes into 12. There's not a greater common one. 2 is a factor of both, but it's not the greatest. Now with variables, assuming they have the same base, the greatest common factor is the one that has the smallest variable, or exponent. Sorry, I'm going to rephrase that. When we look at variables with exponents, the greatest common factor, assuming they have the same base, this is an x and an x, is the smallest exponent. So the greatest common factor is x to the third, smallest exponent. Okay, so to factor using the GCF, we are first going to find the greatest common factor of the monomial. Then we'll write that down outside the parentheses. And essentially what we're going to be doing here is we're going to undistribute. All right, and we're going to write it like it would look like before we distribute it. We'll then divide each term by the GCF to determine what goes inside the parentheses. So we're rewriting it. It's not going to change. So first I have to figure out what goes into 30, what goes into 12. All right, look at the numbers first. The GCF between 30 and 12 is 6. Now with the exponents and the variables, the smallest exponent for the x is x to the first, so I can take out a 6x. So what we're going to do here is we're going to divide both these by 6x. 6x goes outside the parentheses. Inside's what's left over. 30 divided by 6 is 5. X to the second divided by x, you have to subtract the exponents. 2 minus 1 is 1, so we just have an x left. 12 divided by 6 is 2. X over x, 1 minus 1, that's 0, so the x's cancel. Now, you can check your work by distributing. When you distribute, you should end up with exactly what we started with. 6x times 5x is 30x squared, and 6x times 2 is plus 12x. So we got it right. There is our factored format. We pretty much took the problem and undistributed it. Okay, so that's factoring using the GCF. All right, next one. 12 and 18. GCF between 12 and 18. So for sure we got a 2. 3 goes into 12. 3 goes into 18. 4 doesn't work. 5, 6. 6 goes into both. 6 into 18. 6 into 12. I think that's the largest one. So the GCF between these is 6. Now with our x's, we take the smallest exponent, which is x to the second. 6x to the second goes outside. Divide both terms by 6x to the second. 18 divided by 6 is 3. 4 minus 2 gets us x to the second. 12 divided by 6 is 2. X squareds cancel because it's an x squared divided by an x squared. And we are just left with 2. And again, you could distribute it to check your work. All right. On to the next one. GCF between 7 and 9. There isn't one. GCF between x and y. Those are a different base. This one is prime. Can't factor it. That's as simplified as it gets. I couldn't have distributed anything to get that, so this one just stays the way it is. All right, now, typically, if the first term is negative, I'm going to tell you to pull out a negative, okay? If the first term's negative, pull out a negative. So I'm going to take out a negative. All right, what goes into 5, 20, and 10? GCF between 5, 20, and 10 is 5, so I'm taking out a negative 5. Common variable is a, and a. The smallest exponent is a to the first, so I can take out a negative 5a. Divide all 3 terms by negative 5a. Negative 5a goes outside. All right, negative divided by negative is a positive. 10 over 5 is 2. A squared over a, I'm left with a 2a. So if I were to distribute it back out, I would get negative 10a squared. Okay, that makes sense. Positive divided by a negative is a negative. 20 divided by 5 is 4. A over a cancels. I still have a b, so the b has to stay. So I have a negative 4b. All right, if I were to distribute that back out, kind of look through this, I'd have positive 20ab. Yep, good to go. Negative 5 divided by negative 5 is a positive, and anything divided by itself is 1. We got it factored. Okay. Next one, into 8, 20, and 16. That's going to be 4. Y, greatest or smallest exponent for the y is just a y to the first, so I can take out a 4y. Divide all 3 terms by 4y. 4y goes on the outside. Left inside, 8 divided by 4 is 2. Y to the third over y is y squared. 20 divided by 4 is 5. Y squared over y, I'm left with 1y. And lastly, 16 divided by 4 is 4. The y's cancel. We got it. You could distribute to check your work. And the last one, 6, 10, and 16. Looking at the numbers or the coefficients first. What goes into 6? 2, 3. 3 doesn't go in. 3. 2 is the biggest one. 2 goes into 6, 10, 16. Now we look at our variables. I have an x to the third, an x to the second, and x to the second. The smallest variable or exponent for the x is x squared. Now for the y's, the smallest exponent is y to the first. So I can take out a y. So 2x squared y outside. And we have to divide all 3 terms by 2x squared y. Kind of tricky. 6 divided by 2 is 3. X to the third over x squared. I am left with an x. 10 divided by 2 is 5. X squareds cancel. Y squared over y. I still have a y there. Minus sign. Negative divided by a positive is a negative. 16 over 2 is 8. X squareds cancel. Y's cancel. So it's just a negative 8. And we got it. That's it for the GCF. Have a good one.